Parker Solar Probe (PSP). The Parker Solar Probe is a NASA spacecraft launched on August 12, 2018, designed to study the outer corona of the Sun by traveling closer to the solar surface than any previous mission. Its primary goal is to improve our understanding of key solar phenomena, including the solar wind acceleration and the heating of the solar corona, which have significant effect on space weather that impact Earth and the broader solar system. Mission objective: 1. Trace the flow of energy and understand the heating of the solar corona. The Sun's corona is millions of degrees hotter than its surface, a long-standing puzzle. PSP aims to measure particles and electromagnetic fields to understand where this energy comes from. 2. Explore the structure and dynamics of the solar wind acceleration region. The solar wind is a stream of charged particles emitted by the sun that affect planetary atmosphere and magnetic environment. PSP wants to figure out how this wind is accelerated to high speed. 3. Understand mechanisms that accelerate and transport solar energetic particles. Solar energetic particles pose radiation hazard. Understanding their origin and propagation helps space weather forecasting. 4. Provide direct sampling of the near-Sun environment. By traveling closer than any spacecraft before, PSP takes in situ measurements in the Sun's outer atmosphere. Key features and instruments: heat shield, thermal protection system (TPS). The spacecraft features a carbon composite heat shield about 11.43 cm, that is 4.5 inches thick, which keeps instruments safe from temperature up to 1377 degrees Celsius. Instrument suite: measure electric and magnetic field, radio wave and plasma waves in the Sun's environment to understand solar wind turbulence. Wide field image for Parker Solar Probe takes images of the solar corona and solar wind structures. Solar wind electron alphas and protons investigation measures properties of solar wind particles, electrons, protons and alpha particles to understand solar wind acceleration. Integrated science investigation of the sun detect energetic particles and solar energetic winds. Trajectory and orbit: the Parker Solar Probe uses multiple Venus Gravity Assist flyby to incrementally lower its perihelion closest approach, allowing it to get closer to the Sun over time. At its closest approach, it will come within 6.16 million kilometers from the Sun's surface, about 7 times closer than the previous record. Its orbital velocity at perihelion reaches about 690,000 kilometers per hour, that is 191 kilometers per second, the fastest spacecraft ever, allowing it to outrun some solar wind particles and directly sample their source region. Scientific contribution and discovery: since its launch and close approaches, the Parker Solar Probe has made several important discoveries. Understanding solar wind origins: the PSP discovered that the solar wind originates from small magnetic funnels on the solar surface called magnetic switchback. Sudden reversal in the magnetic field lines that causes solar wind to speed up. Coronal heating insights: the data indicate mechanisms like infrared waves, magnetic acceleration plays a key role in transporting energy that heats the corona and accelerates the solar wind. Particle acceleration measurements. Measurement of solar energetic particles helped identify their acceleration close to the sun, shedding light on CME shock front and magnetic reconnection. Dust and debris near the sun. The spacecraft observed dust vaporization event and dust to plasma interaction near the sun, providing data about the solar dust environment. The Parker Solar Probe represents a major space getting closer than ever to the sun, making novel measurements in the solar corona, providing unprecedented insight into how our closest star works, enhancing our ability to protect technology and life on Earth from solar activity. Each data is revolutionizing our understanding of the sun's dynamics and will continue to fuel solar and space science research for years to come. Kindly follow us for more space updates. Like, comment, subscribe, share, and follow. Thank you.